Welcome to Tech in Translation, the podcast where we break down the complexities of today's most innovative technologies into something we can all understand.
Brought to you by Ironbow Technologies, a next-generation solutions provider. We're committed to helping our customers across the government, education, commercial, and healthcare sectors turn their tech challenges into real, actionable outcomes.
At Ironbow, we believe that technology should be a tool for empowerment, not a source of confusion.
That's why each episode of Tech in Translation is designed to demystify the latest trends, tools, and technologies, making them accessible for everyone, whether you're a seasoned professional or just tech curious.
Join us as we translate complex tech into everyday language, one episode at a time.
Welcome back to Tech in Translation. I'm your host for today, Tom Wooten. In this episode, we're talking about the real-world impact of cybersecurity on the critical infrastructure we all rely on: water, power, and emergency services. Joining us is Barry Wood, a cybersecurity professional with a long-standing interest in infrastructure and industrial cybersecurity. Barry's goal is to keep essential systems resilient in the face of today's growing cyber threats. Barry, great to have you here. Can you tell us a little bit about your background and what brought you into this field?
Well, Tom, thanks for having me on. I appreciate it. I came late to the field. I'm actually a midlife career changer. In my previous life, I was a college professor. I have a PhD in art history.
An educator, nice.
But I got tired of the ivory tower, and it kind of dawned on me that, art and technology are really two sides of the same coin, because it's human ingenuity applied to understanding the laws of the physical world and applying them to create values. It's just some are psychological and some are physical, existential. So, the Sistine Chapel and a nuclear reactor are really kind of the same thing. And I realized also that the latter were under attack, because around the time I was doing this thinking is when the Colonial Pipeline hack hit. And I saw how, the whole eastern half of the country was suddenly, lining up to put gasoline in garbage bags and all that kind of thing.
Yeah. Wow, I've never thought about those two even being close to being related, but that's fascinating the way you put that. Cyber threats used to mean email hacks or stolen passwords. Now they can shut down a factory or, like you said, a pipeline. How did we get here?
Well, it's because the factory and the pipeline that you mentioned got integrated into the IT world. I mean, in the old days, there was something called an air gap, which meant that the factory's systems were offline just inside the factory. And, security was a padlock on the door, or a guard at the gate. But eventually, IT and OT converged, and people understood how much efficiency and improvements in safety and visibility and just cost effectiveness and all that computerization could bring, and they started bringing things online. And so basically the outside IT world, if you will, got access to the factories, the pipelines, the water plants, and so on. And that's where the cybersecurity threat landscape came from. It
sounds like when you were mentioning all those, I'll wrap them into one fun word, conveniences of being connected. There was a word that was missing, and that would be security. So there have been attacks on wastewater systems, power grids, and even dams. What do these incidents tell us about how vulnerable our infrastructure really is?
Well, you say infrastructure. The government actually defines 16 areas of critical infrastructure, and these are those areas of life and production which, if tampered with, would materially affect our security, our way of life, continuity of how things go in the country.
Okay.
They include everything from energy or power to transportation, chemical, critical manufacturing, defense, industrial base, and so on and so on. So they are vulnerable in that they're being attacked every day. You can't really think these days, I don't think, of an area of critical infrastructure which threat actors or hackers, if you will, are not trying to mess with.
So when these systems go down, it's not just inconvenience, what you're telling me, it's dangerous. What are the potential consequences if these kind of attacks hit our own communities?
You can answer that question for yourself. Just think of some convenience, to continue to use that word, that we enjoy in daily life and take it away. For example, I mentioned water. I had this experience last summer. I was staying in an apartment building that had been newly rebuilt, literally from the ground up. And so it was brand spanking new. Everything was sparkly. So I go into the bathroom one morning to wash my face or something, and I lifted the spigot and nothing. I mean, no gurgling noise even.
No water at all?
Just nothing. Nothing came out. No water. I mean, we kind of take for granted, it's almost like you think it's inside the wall. And I open the spigot or the faucet and it just comes out. But it doesn't. Now, it turns out it was relatively innocuous. I mean, the people rebuilding the apartment had to turn the water off for some period of time, and just it'd be too inconvenient to, tell anybody they were doing it. So you just had to find out for yourself. But it came back. Now, imagine that it didn't come back, or that you didn't trust the water coming out. I have a better example of water. Literally the first hack on critical infrastructure that ever happened was about 25 years ago in Australia, when a disgruntled ex-employee of a water treatment company decided to get even for his troubles by driving to the sites where he knew the pumps were with a radio and a computer and altering settings from the convenience of his car. And the result was a couple 100,000 gallons of raw sewage spilled out into Maroochy Shire, Australia, befouling local streams and even the grounds of a hotel. And it took weeks to clean up, and it probably reeked to high heaven.
Oh my, yeah, that's terrifying.
That's just water. Think about power. I mean, there have been numerous attacks which have gotten a fair amount of press in Ukraine. Even before the Russian invasion, the Russians 10 years ago were turning off the power in Kiev. I mean, in one attack, 225,000 people were without power. And more recently, there was an attack where in January, they shut off the heating systems in 600 apartment blocks. That's 600 apartment blocks, not apartments. So this is however many hundreds of thousands of people in January in Ukraine, right? Sub-freezing weathers with no heat.
Good grief.
Transportation, there have been hacks. In 2017, there was a very famous worm called NotPetya that spread around the world like wildfire. Well, it hit one of the world's largest shipping companies, if not the largest, which is Maersk. And the Maersk systems got completely bricked in a matter of practically minutes. And I mean worldwide bricked. Their whole Active Directory structure just completely went down. And the chief cybersecurity officer spent 70 days in the office rebuilding the network from scratch.
Good
so
grief.
Don't let anyone tell you that heroes don't exist, because they do.
Okay, so many of these systems, getting back to when we're talking about the air gap piece.
Yes.
Many of these systems were never built with cybersecurity in mind. What's one of the legacy tech problems we're dealing with?
Well, they weren't built with cybersecurity in mind because cybersecurity wasn't an issue for them back then. Back then, the issue was not security, it was uptime, continuity of operations. Things were built to run and run continuously for years and even decades. So there's a if it ain't broke, don't fix it thing going on in industrial control systems where, you have computers that are literally running like Windows XP or even NT because they were built to do that. And it's worked, so why go in and fix it? And on top of that, fixing it can be awfully inconvenient. Because in IT, your computer needs a patch. There's a couple minutes of inconvenience while it, does its thing. Maybe you need to shut down and reboot again. Okay, but you can't do that in an industrial setting. I mean, you can't just take this transformer offline and reboot the firmware or something. A lot of these companies have what's called 5 nines requirements, which is they have to be up and running 99.999% of the time. So in the space of 1 year, that gives you 5.5 minutes of allowable downtime. So it's just not realistic to think that you're going to go in and patch everything.
So if you can't patch everything, then you are ridiculously vulnerable to many of the threats out on the web.
Yes, patching and other factors make industrial control systems uniquely sensitive.
You've said before that the closer an attacker gets to the machine layer, the more dangerous they are. What do you mean by that?
Well, let me explain what I mean by layer. In industrial cybersecurity, the systems let's say a plant, are, for conceptual purposes, divided into layers, which we call the Purdue model, because it was developed at Purdue University. So level 0 is the machines that are actually doing physical work. I mean, they're drilling, they're pressing, they're boiling water, they're doing whatever. Level 1 above that is the systems that are controlling them, like PLCs. Above that, you've got the systems that control those systems. Then layer 3 is kind of site-wide supervisory. Level 4 is the office IT system, and 5 would be like the internet. Okay, so if you go 5, 4, 3, 2, 1, 0, you're getting closer and closer to the actual, like, kinetic, often very violent and dangerous physical actions that industry requires. So hackers can attack the company email system and so forth. That's fairly up there. They can do a lot of mischief at higher levels with things like ransomware. Okay, but level 0 is where things are moving. Heavy, sharp, pointy, dangerous things are moving. And so if they get that far and start monkeying with those processes, that's danger to life and limb.
This is a lot to consume, and it's got some serious shock factor, and I hope everybody is getting that that's listening. So are leaders and organizations finally waking up to these risks, and are we seeing, or where are we seeing improvements?
I think our days of not taking it seriously are definitely coming to a middle, because lots of organizations have woken up. Sometimes it's been a rude awakening, but they've woken up to the threat. There are a lot of excellent, high-powered companies and corporations who are on it. I mean, some of them are specialized, like companies like Dragos and Nozomi Networks. But there's also like Cisco and Fortinet, and large established companies are diving into this problem because, I mean, from our conversation already, it's kind of obvious. It's a serious problem. The government is also in on the game. CISA, so the Cybersecurity and Infrastructure Security Agency, thank you. They have been an invaluable clearinghouse of information. So whenever a new vulnerability in a specifically industrial system is discovered, that goes on their site, and you can get updates. Like I get updates in my email. CISA releases 20 new industrial control systems advisories. But also the feds. What was it? Last year, the FBI shut down Volt Typhoon, which you probably heard of. That's the Chinese hacking into not quite control systems themselves, but they were planting themselves within our critical infrastructure to kind of listen and lie in wait while the FBI shut down their network.
So dwelling.
Yes, exactly. And just last week, the FBI shut down something called the Llama Stealer, which is an information stealer which had been very active in critical infrastructure, and the FBI shut it down.
This is seriously damaging my calm. But let's try to go towards a good side of the story. Can you share the story of a utility company that successfully foiled a cyber attack by having just the basics in place?
Absolutely. Let me define what we mean by basics. So the SANS Institute, which is like the powerhouse in cybersecurity, information and education, they have come out with what they call the 5 ICS critical controls. So the first one is you should have an ICS-specific incident response plan. So you should know what to do if an ICS attack happens because it has different requirements from an IT cyber attack. I mean, you've got machines running or not running. The second one is to have a secure architecture. So things should be segmented that shouldn't be talking to each other. I mean, for example, the internet should not be talking to your pumps.
Right.
Third is you want visibility into your OT operations. A lot of people don't have that. I mean, you can have all of the IT, Windows Defender and whatnot running, but it's not going to see industrial protocols. And so you can run around, hog wild in the OT systems and not be spotted if there isn't OT-specific visibility application running. Fourth is you want to secure the remote access. People need to log in, vendors, customers and so on. You need to make sure that is secure because that's a really popular door into industrial control systems. And fifth is you want to do risk-based vulnerability assessment. So you can't patch everything like we said. You need to pick out the ones that are specifically high risk. Like you got to patch this now.
Criticality and exploitability.
Exactly, right. So those are the 5. Now, I have heard the story. Rob Lee of Dragos tells this story that they were consulted by what he calls a mid-size utility. Don't know what it was. And they get together and Dragos sets up shop and they realize that there's been an intruder in their system for like weeks, if not months. But this threat actor was not able to do anything because this company had the basics right. I mean, it's the equivalent of a burglar gets in a window of your house, but finds himself locked in a room with not much in it. So He's in there and maybe he's jiggling the locks or whatever, but he can't get anywhere or do anything just by having the basics in place. I mean, they didn't know he was there and they didn't have plans to do anything like super James Bondy or whatever. It's just that they ticked the boxes and it worked.
And it turned out to have intruder isolation as a
precisely.
factor.
He got segmented off.
So for the average person, especially working in tech environments, what are some immediate things they can do to improve cyber hygiene?
Well, I mean, if you're talking the average person, I mean, like Miranda in accounting, keep your passwords strong, right? Very strong.
And not on a Post-it note?
Not on a Post-it note, exactly. You want your antivirus up to date. You definitely do not want to click on links in emails. I mean, I mentioned the power attack in Ukraine a couple minutes ago. That started with a malicious email. I mean, they sent an email with malware encoded in a Word document they spearphished various important people, and somebody clicked on it and they were in. And there goes the power. And lastly, don't plug in your own stuff to the network. This is a big problem in cybersecurity generally, but specifically in ICS, is, if you, for convenience, you plug in a router closer to your desk so that you can get on the internet easier, or I just have a cool app on this USB that I'm going to stick in. That's called shadow IT because it's not on the radar and it's bad. Exactly. Yeah, that's bad. For slightly higher level up people like sysadmins, do things like enable PowerShell scripting, because PowerShell is becoming an increasingly popular weapon in the hands of threat actors. So make sure that that's getting logged.
Okay. At first you say enable, and it's like, but why? Because then people can use, no. So you can log it and track
exactly,
it.
Yeah.
Gotcha. All right. So Barry, if there's one message you want listeners to take away about critical infrastructure and cybersecurity, what is it?
That message would be defense is doable, but we have to do it. I mentioned the 5 critical security controls. There's only 5. And, it may be a bit of work to get them up and running, but as we've seen, they work. We should not get into a position of thinking that the bad guys are omnipotent and we are constantly and forever going to be playing a game of catch up. Okay? It is possible to fend them off. They don't have magic. Okay? They have technology. We know how it works and we know how to block it. You just have to be serious about blocking it. Like I mentioned, secure remote access. A recent attack on water systems, in fact, came because the human-machine interface, which is the box that the engineer uses to directly control the process, was exposed to the internet with a default password that you could Google.
It's sad laughter.
Yes, I know. So yes, defense is definitely doable, but we got to do it.
So as you look ahead, where do you see the field going? What are the emerging threats and opportunities in keeping infrastructure safe?
Well, the emerging threats are unfortunately quite obvious. I keep mentioning Ukraine because that's where all the action is right now. For the hardcore industrial hackers, they are throwing everything they have at Ukrainian critical infrastructure. They're learning a lot, and they're getting a lot of money from a certain nation-state actor. Now, when the war is over, that partnership is probably going to continue. So we need to be very aware of the hybrid threat, if you will, that's going to come out of that when it's over. And the same goes for, the conflict between Israel and Hamas and so forth. The bad guys are getting practice, like the Nazis in the Spanish Civil War. They get trained and then they go off and do even worse on a bigger scale. We need to watch out for that. The opportunities, I think, are there for anybody who is willing to do the defense. Companies and security consultancies and so forth need to skill up. They need to hire the right people. They need to do the spend. I mean, IT gets all the budget, but OT is what makes the money. Your widgets, your fruity OT bar is going to come off the assembly line and make the money. So you should put the necessary money into OT security. And that gives us a fighting chance.
Barry, that was fantastic, and I thank you very much for the conversation. If you enjoyed this episode, subscribe to Ironbow's Tech and Translation podcast on your favorite platform. For more information on secure infrastructure and cybersecurity strategies, visit ironbow.com. Until next time.